Morning, everyone. Welcome to the EasyPower Tuesday Refresher Series. My name is Jim Chastain. I'm an applications engineer with EasyPower, and in our Tuesday Refresher Series, we try to amplify certain situations of the application of the EasyPower tools that may be lesser known or lesser taught in some of our training material. And this is true for today's topic. And so I welcome all to the conversation, and hopefully it will be beneficial. And as we are in the mode of starting each session with poll questions, I'd like to invite you to participate in the following poll question. First is, how often have you used a current limiting fuse to improve the SCCR of a downstream system element? Again, there's no liability or downside. It's strictly trying to get some feedback from the audience as far as their take on the topic. For those of you that haven't attended a EasyPower webinar before, we send out an attendance certificate via email. So you want to make sure you've registered with your email address. And that's no further activities required. Just attendance today is what we report on. Okay, looks like we have a quorum. Here's how people have responded on this. So interesting distribution, and we'll receive. Thank you very much. And the second question is basically your opinion regarding fully rated panels versus series rated, which are more expensive. So the question is, true or false, fully rated panels are more expensive than series rated panels? And to be honest, I've never bought a panel, so I'm not an authority on the topic. I'm strictly just trying to gather feedback from the audience, who I'm sure have more experience in this area. So it looks like we have a quorum. I'll close this poll. And we have a good distribution on this one. And looks like almost half the audience is in the same boat that I am. So welcome to the conversation. Okay, well, as you might have guessed, the topic today basically evolves around the element that's available as a protective device called a current limiting fuse. And the definition of a current limiting fuse is that it will clear a fault in the first half cycle as long as the fault current's above the limiting threshold. Now, the amount of current delivered downstream may be less than the peak max of the upstream fault current, but that specific value may vary based upon the parameters of the circuit. And so it opens up a lot of discussion, and some people feel or think that putting a series limiting fuse upstream of any panel will be able to raise the short circuit current rating of that panel. And they base that discussion on what's called the up-down-over method, where you determine what the available fault current is and its intersection on this particular chart with the load curve of the size of the amperage of the fuse, and then where that point, that intersection, moving to the left, intersects the load curve of the peak let through of that fuse, and then plot down will tell you what the maximum peak let through current is for a downstream fault. Well, I'm not authority on this, but I do want to reference a document from the little fuse technical manual power guard, which I've included a copy in the handout. And I'm going to come back to the first paragraph later, but what I want to focus on is what I've highlighted in yellow, starting at number 1, provide backup short circuit protection for large air power circuit breakers and enable non-interrupting equipment such as bus ducts to be installed in systems with available short circuit currents greater than their short circuit withstand ratings. However, this method may not be used to select fuses for backup protection of molded or intermediate frame circuit breakers. And then they stipulate or quote the National Electrical Code, Article 240.86. So what that's in reference to is the topic or the discussion of fully rated versus series rated equipment. And what we're talking about is the interrupt rating of the overall downstream system. So in this particular example, I show on my one line that we have upstream a overcurrent protective device, which may be a fuse or a breaker, that's rated for 65,000 amps. And each of our protective devices on the downstream bus are also rated for 65,000 amps. So in this particular configuration, this is regarded as a fully rated system. Now you can see we have fault current available on this bus, a short circuit fault current of 31,400 amps. And that means a downstream fault the current will not exceed any one of the ratings for these protective devices. Now, going to the National Electrical Code article that was referenced in that application note, Article 240.86 defines series rating as a device combination that must meet the requirements of A or B and C. And A is selected under the engineering supervision of an existing installation. It must be documented, and you must ensure that the downstream device remains passive during interruption period of the fully rated limiting device upstream, or the device combination tested and marked by a lab or the manufacturer. So one of these two conditions must be met to be able to qualify as a series rated devices, and then the device that series rated cannot be used where motor contributions is not included. So if that's not confusing enough, I don't think I could make it more confusing if I tried. But what it boils down to, and the motor contribution problem is significant, what it boils down to is if we are trying to evaluate this breaker being series rated or qualifying as an upstream device for a series rated configuration, then it can't be used in a conjunction with a panel where there's multiple motor loads that will supply current into a fault. For instance, the 3E2 bus, if it were to fault, there's motor contribution current from each one of these sister motors, if you will, that won't be felt by the upstream breaker. So in this case, series rating cannot be used. Okay, so that's series rating. That's the definition of fully rated. Now, series rated means that the upstream overcurrent protection device is tested to interrupt, or is fully rated to interrupt the fault current. So in this case, again, we have the fault current of 31,400 amps, and our main protective device is rated for 65,000 amps. But the downstream devices are only rated for 10,000 amps. So based upon the manufacturer or some technical body that's qualified to do so, having tested the combination of the two devices to be able to protect the downstream fault, then this would be considered a series rated situation. Now, it's likely that if we had a downstream fault at any one of these feeders, both devices would trip. So we've lost coordination as a result of that, but we've eliminated the need to have a fully rated device downstream. And so according to conventional wisdom, this type of arrangement is found on price competitive commercial projects. And EasyPower does not provide rating for fuses that are being used in series rating applications. And so there's no lookup that you can verify what the series rating is for a fuse. Now, when the upstream device is a breaker, then EasyPower does provide series ratings for breakers, and these support, or these are confirmed by manufacturer's test results. Okay, bear with me. So again, it's likely that both devices, in the case of a downstream fault, may clear, but they would do so at the 31,400 amp fault current, in spite of the fact that it's higher than the rating. So the point is, this is a passive device in that situation, and what we're depending on is the upstream properties of the protective device to protect the downstream system, and for that matter, the panel itself. Okay, now I say that we can go to series rating, in this case square D rating chart for their breakers. They list for a 240 volt system, the maximum 100,000 amp rating. If I have a line side fuse that's an LPJ, more than 600 amps, it will have series protection for these types of breakers, these square D breakers. So this is information that the manufacturer has tested, and we're relying on his test results to be able to do this series rating application. And so if we look at a system that's has a maximum of 100,000 rated protection, if we have a line side fuse of an LPJ, no more than 600 amp rated, and it will protect one of these devices. So let's see how this looks. So here we have a J fuse, and a BL2 is a KA. And if we go into EasyPower, we can find what that looks like in the one line. So what we're talking about in the EasyPower one line are the short circuit ratings for each of the devices. So here's the J class fuse. If we open up its properties, we can see for short circuit, it's rated for 200,000 amps. So it's clearly greater than the 100,000 amp short circuit fault current downstream. If we look at the rating for the KA breaker, it's only rated for 42,000 amps. And now let me just kind of make a side note. None of this discussion has anything to do with arc flash. We're strictly talking about equipment duty. So if I go to short circuit focus and I look at a half cycle 3-phase bolted fault, I see that in fact I have 50,000 amps fault current and 36,000 amps fault current downstream. And if I look at equipment duty, I see I've over-dutied my breaker by 27%. Again, this is a threshold that's set in my controls, and I'm saying if I'm more than 10% over my duty rating, flag it. And if I'm over the duty rating at all, make this a positive number. So we're 27% over dutied, in the case of a downstream fault. So if we go back to our database view and we subscribe to that apps note and the relay information from Square D, and I need to, it's rated for up to 100,000 amps with that combination of elements. So what I want to do is manually change. Now, if I can deal with the fact that this is not going to have, if it's not going to bother anybody to show that that's overdutied, I can live with it. If I want to erase that, I would change this manually to what the app note says, and then I detail this in the comments section, showing that we have a 100,000 amp rating based upon an upstream fuse being an LJ less than 600 amps. And by doing that, now when I go back to short circuit, fault all the buses, and look at my equipment duty, it's no longer in violation. And if we look at our equipment duty report, we see that that breaker is rated at 100,000 amps. Now, what is this? What are the complications of making this adjustment? Again, we've made it manually, so there's no lookup in EasyPower. We've documented it on the one line. One of the requirements in the National Electrical Code, when you've done something like this, which is manually combine a restriction on the upstream device versus the downstream device, there's a labeling requirement. And the question is it going to be followed, or is it going to survive time with people working on this panel or breaker? In this case, this is a breaker downstream that has a series rating for an upstream, I think another breaker. But the point is that we need to label the location so that people just can't go out and exchange without the full information. So that's an obligation, or that's a problem that comes up when we start talking about series rating. And that's why you need to have it tested, especially if you don't have the application information from the manufacturer. You want to make sure it's tested for your particular configuration. Okay, this takes us back to the up over down method. And in this case, where we have a downstream device that doesn't have a protected device in it, but it has an SCCR rating. In this case, it's rated for 22,000 amps on this particular panel. And we know it's going to get receive 100,000 amp fault current if a fault occurs at that point. How do we deal with that based upon the up, down, over method? So what we do is what the fuse manufacturer suggests is that we can plot the 100,000 amp available fault current up to where it intersects our value for the fuse itself. In this case, I think it was 600 amps. We take it over, and you can't see. Intersect the 100,000 amp value on the bottom axis, take it up to where it intersects the value of the fuse line, and then over to where it intercepts the load line, and then go down, and that will give us the total of current that will be delivered to the downstream load. So in this case, it looks like if we have 100,000 amps fault current and a 600 amp fuse, then it's going to limit the downstream current to 18,000 amps. Now, does that mean it's tested? No. Does that mean we can just blindly go through and do this? No, it doesn't. But it does indicate that there's some possibilities for reducing the cost of the downstream device, or not having to beef up the protection that's included in our load. So this is a workaround in EasyPower. In this case, I've annotated what's going on the one line, and I've presumably put some sort of labeling on both the fuse, because that's a critical part of the equation, and the load to verify what I've done. So it brings us back to the original question, and that is, why does EasyPower not support the up, down, over method? How about up, over, down method? The fact is, it's a complicated decision, and even the National Electrical Code requires a qualified engineer to make the assessment of both the series rated combination and the ability to calculate what the maximum downstream current is in the case of the use of the current limiting fuse. So it impacts long-term considerations. For instance, labeling. For instance, maintenance. If a fuse blows, what are the restrictions, or what are the training for an individual that's going to try to keep the system up and running? And is this information on the up-down method properly documented such that they can't override or change the fuse indiscriminately? It does require local expertise to evaluate the alternatives. And frankly, the conservative approach is to make sure the decision is made locally rather than EasyPower with some sort of a lookup table that has no real bearing on what your physical setup is in your system. So hopefully, I encourage folks to understand what this process is. And this brings me back to the discussion in the apps note. And that is this last line of the first paragraph. When protected by a 600 amp RK1 fuse, the equipment short circuit rating of 22,000 amps may be safely connected to a system having 100,000 amps available. This method is referred to as the up, down, over, but it's not frankly encouraged and has nothing to do with the let-through energy on arc flash calculations. So don't confuse the two, as well as it doesn't really apply to series ratings for active devices. Okay, that does it for today. Appreciate your attendance. Be happy to answer any questions. And if you'd like to contact me afterwards, you're welcome to shoot me an email. Make sure you check out the EasyPower newsletter for update on webinar schedules and training schedules. And I hope you have a good day.